Hi, everyone. I'm Jim Cahill with another Emerson Automation Experts podcast. Today, we'll open a 4-part series by exploring the role of control technologies in helping drive efficient and reliable LNG production performance. Emerson's valves, regulators, and actuators empower the entire LNG value chain from liquefaction to the transport and terminal of LNG, and from project startup and commissioning to long-term facility operations and maintenance. Emerson's Reid Youngdahl joins me to discuss a great success story in which a Fisher JT control valve improved the performance of the main cryogenic heat exchanger at an LNG plant in Europe. Welcome, Reid.
Hi, Jim. Thanks for having me.
Hey, it's great having you here on the podcast. Let's begin. Can you share your background and path to your current role here at Emerson?
Sure. So I've been with Emerson for 11 years now. All that's been within our flow controls Fisher organization, primarily Fisher control valves, and that's been located here in our global headquarters up here in Marshalltown, Iowa. So my current role is a valve technical specialist. So I have the privilege to provide global support for our products. We're kind of broken up into industry groups to kind of provide better support to our end users. So primarily my applications are severe service support for the oil and gas industry with an emphasis specializing in LNG. So whether that's working with EPCs, doing sizing selection, consultation on large projects, or that could be supporting troubleshooting valves out in the field. So, and then through that process, through the years, have had the opportunity to work on a lot of these critical JT valves that we'll be talking about today, Jim.
Well, that's a great background there. And yeah, I would think LNG with cryogenic temperatures is severe service kind of. So I look forward to our discussion. Now, where are some of our isolation and control technologies found in LNG?
Yeah, kind of like how you opened up, Jim. A lot of the Emerson Final Control brands and products, can be found throughout the full LNG value chain, whether that's honestly taking gas out of the ground to liquefying it to shipping it and regasifying it. So likely if you're walking through an LNG facility, you're likely to come across some Emerson Final Control equipment, whether that be Fisher control valves, whether that be isolation valves, or even pressure relief valves. So we do have an extensive global install base. Not going to stay here and list everything out, right? But even starting here in North America, right, places such as Cove Point, Rio Grande, Golden Pass, Port Arthur, Venture Global, even Energia Costa Azul. So a lot that have already been built, like Cameron and Cove Point, and a lot of things that are in the process of being built and constructed, as well as overseas. We have an extensive overseas install base. Some notable ones, right, would be Qatar Energy, LNG, the big mega trains, extensive experience in there. And whether that be even remote locations such as like a BP Tangguh facility. So a lot of shapes and sizes in terms of the LNG capacity that we have experience in. And honestly, not only just onshore, but floating as well. So things such as Shell Prelude FLNG. So again, not everything, but just a few things to note.
Well, that sounds like it's basically spread all over the globe with some of our final control products. That's great. I wanted to ask you about a fascinating case study where an LNG producer implemented a Fisher JT control to improve the performance of a main cryogenic heat exchanger, or I guess the acronym MCHE, at an LNG plant in Europe. What challenges was the LNG plant facing, and what specific applications were being affected?
Sure. Yeah. So we were contacted from our local sales office over there, and I think it's just good to. I kind of like to take a step back too, and just remember that even though it's often overlooked, these JT valves around the main cryogenic heat exchanger, are really, if you talk to other LNG end users, are the most important valves in their whole facility. So often overlooked, but it's the truth. And a lot of that is because, these are directly coupled to that main cryogenic heat exchanger. And that heat exchanger is kind of the heart of the facility. That's where you're making your LNG, right? So these valves are controlling the flow, controlling this cooling kind of going on in there. So again, if those JT valves aren't operating well, the whole facility feels it and knows it. So that was the case for this end user. Since startup, they were experiencing issues, really largely resulting around just not getting the control they needed. There was a lot of inherent friction and deadband in those larger control valves, right? These were larger 14-inch, 16-inch globe valves, cryogenic valves, class 600. So again, a lot of built-up friction in there, so they just weren't able to hit the small step changes they need to really be able to optimize that process. So again, they were running things suboptimally. They had to keep this thing in manual mode versus auto mode, right? Automatic. So again, this is a 24/7 type application. This isn't like a batch process. Once you turn this thing on, this thing's going. So again, that's 24/7 operator intervention, and just you got to detune the system and suboptimally run it. So again, they were just experiencing some issues there. And when I say deadband, right, I mean that's kind of a control valve terminology we use in terms of like what is the actual smallest step change I can give this valve or final control element and actually see some change in flow or movement, right? So at what percent can I give it to actually see that plug stem move and actually get some flow out of it? And so, typically, we say like less than a 1% deadband plus hysteresis value is good for a control valve, but these are just very unique applications where if you really want this heat exchanger to be run optimally and really be aggressive, they want way less than 1%. And after working with this end user, they were truly wanting like down to 0.1% type throttling control out of this large valve assembly. So again, close collaboration, just kind of understanding what are the pains, what are the needs. So if they had the perfect valve, what would that look like, right? And see how close we can get. So they gave us a lot of those things to us there. And it's kind of the irony in a control valve is typically it's a controller, right? We're controlling to a process that's tuned a certain way, but usually we're not given any actual control requirements, right? Usually we get a stroking time maybe. So really just working with them on, all right, what's the deadband, what's the dead time, what's the overshoot, and really dialing that in. And then they also had some additional kind of upsets and shutdowns due to, we got to remember these are cryogenic, right? So being able to have the cryogen extension bonnet being sufficient enough for theirs, or was insufficient, so they were getting a lot of ice buildup. Again, this is a non-Emerson assembly, and the positioner they were using had a mechanical feedback versus non-contact. So just due to high vibration and freezing up, they were getting some feedback errors and some failures there. So it was kind of a compilation of things, but again, it just caused them a lot of pain. And again, they were kind of just having to live with that for a while. But again, just being able to close collaboration and figure out where really those pains are coming from.
Well, that does sound like a number of challenges, just operating it manually and having the shifts going around the clock and trying to keep it running. And I can see how it would need to be detuned and large deadband. It sounds like a lot of different things, which means, they were operating a whole lot less efficiently than they could be. Now, I've heard the phrase Joule-Thomson effect used in the liquefaction process at LNG plants. Can you explain what this is and why it's so crucial?
Yeah, again, just not to go into too much detail, right? It's just Joule times is just the thermodynamic process of fluid cooling, right, when it's expanding. And typically that's going to be achieved by taking a pressure drop, across the control valves. And, specifically for these large scale LNG facilities, to get the cooling they need and all that, you're talking about some really high pressure drops. So that's kind of what also makes this a severe application. Not only is the temperature really cold, we're talking about negative 250 F around there, Fahrenheit. But again, you're taking as high as sometimes like 1,000-pound pressure drop, PSI drops. So again, it's going to depend on the technology and the facility, but I've seen those as high as 1,000. And so yeah, it's cold, really high pressure drops. So it's a very severe application. So not only do I want to get good control out of it, but you got to be able to handle that pressure drop. So again, making sure that the valve body is sized correctly to handle that flow and that expansion. Making sure the trim is properly selected to be able to, again, handle those pressure drops while mitigating any kind of vibration. We don't want to see that. And I've seen that happen out in the field. So doing our best to select that. And again, too, just choosing the right materials, making sure things are erosion resistant, hard faced, minimize any galling or erosion that's happening there. So again, in terms of these valves, it's a pretty severe application. And on top of that, we want this thing to control real tight. So it's possible. You just got to make sure everything's kind of engineered and detailed correctly and factory accepted and tested to make sure that all works out.
Yeah, it's not like the AC units in our house that will cool the air, 20 or 30 degrees. It's a little bit more to get it down to cryogenic temperatures.
Exactly. A little bigger scale.
Yeah, just a different order of magnitude there.
Exactly.
So why is it so critical to have precise control over the cooling process of the main cryogenic heat exchanger?
Yeah, and again, I don't want to... there's obviously a lot of important critical assets, obviously, within a LNG facility. What's nice about the different LNG technology, it's pretty well defined on where are the critical valve applications. We have a lot of good resources out there, whether it's the inlet feed valve, controlling everything coming in, the rich amine letdown valve with a large outgassing effect, compressor anti-surge, right? But in terms of the LNG facility, as I mentioned earlier, really it's critical to have precise control around that main cryogenic heat exchangers, because that's really the heart. It's going to be the heart of the facility. Everything in that facility really is revolving around that thing, because that's where it's making your LNG, right? That's going to be your selling product there. So again, heart of the facility, and so being able to have that working correctly and trying to meet the design spec of those, trying to meet that throughput, and not only trying to meet throughput, but also efficiently. It's going green and using less energy to produce more LNG is also a big case. So if I can efficiently operate this, maybe I don't need as much compression, and utilities cost and power consumption goes down. But I've seen LNG licensor marketing materials. They market different advanced process control schemes, right, and algorithms to really be able to supercharge these things and get the LNG throughput. But I've seen the marketing literature, and there's images that actually show the main cryogenic heat exchanger, but around that are all these JT valves in that loop, right? So I think it's always good to kind of take a step back, and you're only strong as your weakest link, right? So I could have a really nice advanced process control scheme, but man, if I don't have the final control elements that can actually meet this type of performance, you're going to be left to whatever that weakest link can do. So that was the case for our end users. So after we were able to work with them, we were able to kind of get them to where they wanted to be.
Yeah, that sounds like you could have the finest of control, but if you have deadband issues with the valve and other things, it's the thing that's actually controlling the process to what it needs to do. Now, I know our Emerson team provided a special Fisher JT control valve as a solution in this instance. What specific capabilities in this valve made it suitable for the challenges they faced at this LNG plant?
Sure. So this one was a bit unique just because there was a lot of really extensive dynamic. I mean, they literally gave us a spreadsheet of performance they wanted to hit, right? Because they know what they wanted. They knew the capability of what that main cryogenic heat exchanger could do. And so this was their bottleneck, right? So there's a lot of close collaboration to understand what their desired control was to be, understand the application. A lot, it kind of depends on the LNG facility. A lot of the times, these LNG facilities will have kind of turbo expanders or mixed refrigerant LNG hydraulic turbines that are actually taking the pressure drop across it, right? So they're actually able to get some energy out of it. So these are really more bypass valves for startup and commissioning. But I've seen a lot of times too is that's assuming that those turbo expander or those hydraulic turbines are working correctly. So if those are out of commission or having issues, then you're back to that JT valve doing all the work. So again, it's important to have that there. But I say that because the end user that we work with, they didn't have any of those installed, right? So these valves were, if that plant's up and running, these valves are going. So some understanding them, because a lot of we get, we quote to projects, we have to meet project requirements. And usually the only requirements we have are like really tight shutoff, isolation valve type shutoff kind of requirements. We don't have anything really on control. So really that kind of pushes these valves into, really higher friction type devices to meet really tight isolation valve shutoff when really, these things are always controlling. They don't need to shut off. So having that conversation, class 4 shutoff was okay here. So that allowed us to use kind of a lower friction cryogenic seal. Because that's the thing too, is to really hit these BS 63, 64 tight shutoff scenarios. It takes a lot of these balanced valves with the cryo seal rings can add a lot of static friction in the valve. So being able to knock down that static friction really helped drop down our deadband and controllability. Also meeting all these really high seat loads likely, typically results in oversized actuators. So big actuators can maybe mean a little bit more dead time and stroking time and controllability implications there. So again, having just that conversation, understanding the process, class 4, this is controlling, this is not shutting off, really opened the door to being creative and really getting them a really good throttling valve. So that was key there. Obviously, selecting the right trim in there. So our typical solution here would be kind of a flow up Whisper 3 type trim. So it's a drilled hole to kind of help split up the jets here while you're taking this large 2-phase or flashing construction. But again, that's all depends on what's happening. It's all based on the vapor pressure. I've seen this be cavitating service too, and we would kind of change our trim there. Making sure that bonnet extension was sufficient, right? Based on our history and our experience, it is. And again, these are larger 14 and 16 inch valves, so good size globe valves. And really, it's all coupled together with our high performance actuation and our field view DVC 6200 positioner. So making sure that's DVC is optimally tuned. That non-contact feedback is really a key player here, right? In severe service application. So it handles the vibration well. Very, very accurate, really able to hit those small step changes. And again, really what kind of helped kind of put a bow on this is, we can say we can do it, but prove it. So we prove that actually in the cryogenic pit. So we'll actually put this, that's pretty standard for a cryogenic valve to require cryogenic seat leak testing, right? So you put it in the pit, put it down to negative 320 degrees, and see what the seat leakage is. But in addition to that seat leak, we also put it through its full course of dynamic performance requirements. So small steps, large steps, frequency response tests, overshoot. Again, so putting it in the elements down to that temperature. And again, this thing responded to less than 0.1% step changes down to 0.0625, which is a 16th of a percent. And again, no pressure across the valve at this point, right? We're just in a static pit here. But again, really being able to tune that thing and get it to where it needs to be. So yeah, that's what's always unique about a control valve is it's not like it's just a single piece of equipment, right? It's a lot of things that have to be manufactured, installed, and calibrated that have to work together there. So yeah, it's from the outside, it might look like a standard product or a standard something out of a bulletin, but it just a lot of the kind of behind the scenes just to make sure that everything in terms of installed friction and everything like that was gonna play out the way we wanted to.
Yeah, it sounds like a whole lot goes into it for this severe service application, from the valve itself to the seals used to the whisper trim type that you have in there to meet the requirements for that application. So I guess, how did the implementation of the Fisher JT control valve improve the plant's operations? And I guess particularly with regard to the MCHE.
Yeah, so of course, after that was all factory acceptance tested, that was done here in Marshalltown, Iowa, and manufactured and tested. We shipped that over. So yeah, we retrofitted a couple of the trains there. They got that all commissioned, and yeah, really in particular, the main cryogenic heat exchanger is, again, getting these installed. A real high level, right? Summary is, right, no longer in manual any mode. You can run this thing in auto. It's going to respond the way they expect when the DCS tells this thing to go. It goes. So really just being able to fully leverage what they had already ordered, right? So being able to run that full master rate LNG controller and full cascade, being able to use all these advanced process control algorithms that they had originally wanted to. So again, not only just getting an operator off this 24/7 and reducing any human error, right? But we're putting this thing in auto, and then that's when you really can supercharge this thing and get it to run where you really want it to, especially when you can get 0.1 type step responses and on a repeatable basis, right? So a really low deadband type device. It also really helps out with kind of the cool down of that main cryogenic heat exchanger. So again, being able to do that on auto versus manual kind of cuts that in half. So again, really helps out with any kind of MCHE cool down or kind of shutdown or startup or any kind of transients there. So yeah, it was a huge success. They really liked it. It was definitely a team support. The other wrench in this too was this is all during COVID. So right, that was always that added another element to this one. But yeah, I mean, ultimately it allowed them to actually get a full LNG cargo ship of LNG throughput a year. So again, it was huge gains. It took a lot of work from everyone's part, but it was good results.
Yeah, it just sounds like if you can get away from that manual control, if you can let the controls do their thing by having, a valve and a digital valve controller that gives you great controllability there, that you can just get a lot more efficient with it. So
yeah, that's actually sometimes is one of my red flags, or one of those questions, right? Is you can is your JT valve running in auto or manual, right? And usually right off the bat, based on that answer, kind of gives you some ideas of what's going on there.
Yeah, and probably an idea what kind of efficiencies that you're missing out on by not being able to go automatic.
Exactly.
So I guess, stepping back a little bit, how does this case study and what you've shared here with our listeners reflect on Emerson's approach to solving these type of complex problems in LNG production?
Yeah, I think it really just kind of start, Emerson in general, right? Fortunately, we have a really in-depth product line here that can really satisfy. Typically, really anything is thrown as it, but really I think what made the difference here was just the close collaboration, right? So just, sure, we can make some assumptions, right, and guess on some things, but just really truly understanding the process. They're the experts, they know their facility the best, right? So understanding if you had something ideal, what would that be? And holding us accountable to meeting these things, right? And challenging us even as vendors. Really kind of led to a really neat solution. So again, being a little bit creative on, okay, sure, the original spec sheet says this BS 6364, really tight seat leakage, all this. Is that really required? Oh, no, that's actually not, because it's those kind of things that probing a little bit more and having those questions really unlocks a lot of different things that a vendor can do in terms of our design, right? Versus just making an assumption that this looks like it still applies. So again, just that close collaboration, working together, and really everything making sure that all plays out in terms of that installed friction, low friction cryo seals, leveraging that FieldView DVC 6200. That really just is the cherry on top in terms of making that work. And then also, right, I mean, that's we didn't really talk about that either, but like being able to leverage the diagnostics too, right? So not only once you get it installed, being able to monitor the friction in the valve, monitor any supply pressure or supply droop issues, any leaks in the tubing, right? All that. It's kind of nice to have a pulse on a critical asset like that when you can leverage that FieldView DVC 6200 Fisher positioner.
Yeah, the diagnostics is huge. Just, you get that efficiency gains from getting much better control out of that valve, but being able to see how it's going over time. You're right. That's a really significant piece there. And I guess as we start to wind down here, what advice would you give to other LNG producers, maybe that are facing similar challenges with their control strategies?
Yeah. I guess I would just kind of ask, maybe just because they're used to a certain kind of performance, maybe not to settle on that or challenge that. Again, takes definitely some extra diligence and making sure something is engineered and tuned and manufactured correctly. But we've proven that even with large assemblies, cryogenic assemblies, taking large pressure drops, all these kind of things, severe service application, but you can still get really fine control. Again, like I was saying, we're hitting less than 0.1% step changes, and they're really kind of I think that's just not really seen as even possible, right? But it is possible. It just takes a little extra details there. And so again, that kind of challenges, if that's possible, then what could be possible in terms of maybe optimizing that main cryogenic heat exchanger or optimizing that unit? Maybe either that's increasing the LNG throughput. Again, if things are in manual versus auto. So yeah, I think just, bring us the challenges. I enjoy getting those things in my inbox, right? All of our inside sales engineers do that. And we like the challenge. And yeah, just kind of being open to, all right, maybe that was on an original project spec sheet, but what's kind of the real requirements of this application? I apply that really to any kind of severe service control valve we look at, right? As if I have a fresh lens here, sure, that was what it was previously said, but knowing this application, is that really required? Our end users know their stuff the best, right? So those kind of questions kind of unlock other opportunities for a control valve vendor to get creative and even get them a more optimized solution.
Yeah, it just sounds like with such an energy intensive process like LNG is, that anything that you can do working within that collaborative fashion to figure out what are those real requirements can lead to tighter control and I guess better efficiency overall. And I guess
I was going to say too, Jim, the energy intensive, it's like, because a lot of these are, trying to go minimal emission, go green. And, if these things are I know some units that are like electrically driven, gas turbines and compressors, right? And, it's not uncommon for these things to consume enough energy to run a city, So again, any kind of, even small percentages can really make big gains in terms of even just energy consumption reduction.
Yeah, I think for our listeners that know what their AC does to their electric bill to go all the way down there, what kind of energy consumption they're going through. So we can definitely help with these kind of valves.
Yeah.
And I guess just to close here, where can our listeners go to learn more about our LNG valve solutions?
Yeah. There's a lot of good resources out there, Jim, specific to, I guess, on this topic, right? Like Fisher control valves, right? Fisher has a nice LNG brochure that kind of walks you through the typical severe service applications, whether that be, a lot of the major LNG licensors out there, whether that's Air Products, ConocoPhillips, Cascade Process. So kind of walks you through the nuances, the inherent implications for those, and the typical applications you can see. The final control, Emerson has a nice final control LNG brochure that walks you through the value chain and all the different Emerson final control products, right? So not only control valves, but relief valves, actuation, isolation valves. So that's kind of a nice walk through there. We have some dedicated web pages. So if you just Google Fisher JT valves or Fisher Joule Thompson valves, that'll bring you to that page. So we have a lot of good resources just dedicated to the JT valve in terms of case studies, articles. I've written a few articles on this, and just the criticality and things to look for. And then kind of summarize, you can really find all this is found in our website. You can visit emerson.com /LNG valves. So that's really if you have one-stop shop, go there and you'll find what you need.
All right. And I'll add links to a lot of those in the transcript that we put out with the post for all those things you highlighted. Well, Reed, I want to thank you so much for joining us today.
Yeah, of course. Thanks for having me, Jim. It was a pleasure.